Hello everyone, welcome back to the next video. So today we'll be talking about benefits, enjoy smooth animation and a gesture-driven interface at 60 fps. There is no single right way of doing animations in React Native. The ecosystem is full of different libraries and approaches to handling interaction. The ideas suggested in this section are just recommendation to encourage you not to take the smooth interface for granted. What is more important is painting that top-down picture in your head of all interaction within the animation and choosing the right ways of handling them. There are cases where JavaScript driven animation will work just fine. At the same time, there are interactions where native animation or entirely native will be your only way to make it smooth, and with such an approach the application you create will be smoother and snappy. It will not only be pleasant for your user to use but also for you to debug and have fun with it while developing. Replace Lottie with Rive. Leverage state machines to provide robust interactive animation at 60 fps. Issue real-time animation suffering from low fps file size and not being robust. When we talk about interactive mobile apps, we often think there will be using certain user driven animation. For example, we can think of getting a nice order placed animation when we complete a checkout. A more complex example would be onboarding step, where the user has to tap on various buttons to move forward, and in most cases each step shows a nice animation. So how can developers implement such behavior? One approach is using GIFs. If we have 3 onboarding steps, then we will want to have 3 GIFs, and often this solution is good performance and UX wise. But what if we need more fidelity in our animation, or when it needs to be high quality? Maybe full screen GIFs can quickly add few megabytes to our app bundle. So what are other animations do we have? Let's talk about Lottie, a mobile client for Android and iOS, which was created by the developers at NPNB to leverage Lottie files, which is a JSON-based animation exported using the plugin Body Moving from Adobe After Effects. They have pretty good community with a lot of free-to-use animation. If we look at the React Native Lottie library, it is pretty popular and well received by the community. We can control the animation using the progress proper using imperative methods such as play. There are other useful props that we can use to suit our needs. Let's compare the size of a Lottie JSON file and a corresponding GIF. If we compare the JSON 46 KB and the GIF 164 KB, which is almost 4 times as much as JSON, we can further reduce the size of JSON using optimized JSON, but that's a paid solution. Now, if we recall the above approach of having separate GIFs for each onboarding step, we can now use Lottie instead of GIF. Since it's smaller, we can also use the remote resources of Lottie JSON instead of having it bundled, but an extra effect will be required to keep it available for offline purposes. We can still do better, but how good will that be if we use a single animation, control it using triggers? For example, if we tap on a button, the state of animation changes for the next step. Let's say we want to change the size or do other customization. We can't do it in the editor provided by Lottie file. Instead, we will have to import that in Adobe After Effects and then do the adjustment and re-export it as JSON. We can, however, customize color for layers in the web editor. Not everyone has expertise in Adobe After Effects and has an animator to consult. Example, if you are working on our pet project, we will want to adjust any animation in the web editor. There are other factors around performances associated with Lottie, which we will discuss in next section. Solution: leverage developer friendly tools which offer better FPS with less file size. There is a new tool in town called Rive. It aims to be an alternative to Lottie by providing everything Lottie does and then some. It also ships a web editor to customize real-time animations on the go. The editor allows the user to build interactive animation which has the capability to interact based on the inputs provided by the user. Having trigger-based animation is a great win, especially for mobile platforms. Remember the approach we took for the onboarding step animation. Now if we use Rive animation, we can leverage its state machines, triggers and user input to use a single animation file for our onboarding step. It really helps in improving the developer experience. In the cherry on the top, the size of the animation file is very small compared to Lottie.json. We also don't have to keep different files for each onboarding step, and saving some KBs for the bundle as well. So here is an example of Rive. As we see, adding complex animation is developer friendly. We can also add triggers or input based animation quickly. All we need is the information regarding the state machine. Inputs and triggers. If we have an animator who build a beautiful animation for our project on Rive and Animate Editor, we can ask them to pass along the info. Otherwise, we can always look up this info in the web editor ourselves. Now let's talk about performance in terms of FPS, CPU and memory consumption. Low comparison of an animation that is built for Lottie with the same animation built for these two. It shows some benchmark done for the web platform. We'll also extend this by using the same for Rive and Lottie on our React Native app. So Rive benchmark this on a Sony Xperia Z3 model using an Android profile perf monitor that is shipped with React Native. If we disable the dev mode so that our JS thread doesn't throttle because of it, both images show a tiny window right above the rocket with the details of FPS on both UI and JS thread. The results show that Rive animation run almost at 60 FPS, whereas Lottie runs at 17 FPS. Now let's focus on the right path of both the images, which is the memory consumption detail. If you look at closely, there are three positions: Java, native and graphic. Java represents the memory allocated for Java or Kotlin code. The native represents the memory allocated for C or C++ code. The graphic represents the memory used for the graphic buffer used to display pixels on the screen. In Java, Lottie uses almost 23 MB, Rive uses 12 MB. In native, Lottie uses 49 MB and Rive uses 25 MB. In graphic, Lottie consumes 123 MB, whereas Rive uses 184 MB of RAM. The total memory consumption of Lottie is 246, Rive is 276. The results show that Rive outperformed Lottie in all departments except graphics. The end user expects they have to run at FPS to enjoy smooth. If one has to do a trade-off between memory consumption and FPS, they might go with FPS, as most of the devices have enough memory to exercise the apps need. Benefits are reduced regression cycle while developing a feature and a happy user base. So we will discuss about this in the next video. Thank you for watching. Bye.